All right. Welcome everyone to today's protocol meeting, where we'll discuss two core advancement proposals. Graydon will be speaking about CAP 65 that introduces a reusable module cache, which Garand actually alluded to last week. And after that, Dima will speak about CAP 64, which pertains to Soroban authorization and memos. With that, I'll hand it over to Graydon.
So this is probably the smallest CAP that I've done so far, and certainly the simplest to describe, but it does actually have a fairly dramatic effect. Um, this really only makes sense in the context of CAP 62. So this is CAP. Sorry, no, I'm CAP 62. This only makes sense in the context of the other CAP. Yeah, no. Sorry. I'm doing CAP 65. This makes sense in the context of CAP 62. Sorry, getting all my 60s tangled up here. So in 62, Garen pointed out that we're in a position where we can basically keep the live ledger state in memory constantly because of the ability to evict live state to disk and account for the movement of data between disk and memory explicitly in protocol events that are surfaced to the user, so the user can tell what they're paying for and what they're getting out of paying for the things being in memory versus allowing a TTL to expire and having it move to disk. And that obviously produces the ability to reduce I/O costs, but there's another thing that we can do on that load or evict event when things move from disk to memory or memory to disk. That actually sort of solves a problem for us that we have had for a long time that has been holding us back from doing something very obvious. So it's a very obvious optimization that we've wanted to do since the beginning of Soroban, which is to cache the compiled, ready-to-run version of any given smart contract in memory in its ready-to-run form. So the WASM bytecode that you upload is essentially not ready to run. It has been validated when you uploaded it, but theoretically it should be validated again before running, but also it gets translated into a sort of a secondary internal format for execution. And in the future, if we ever use a JIT, this will actually be an even more involved process, but there is nonetheless, even with an interpreter, there's a translation phase. And the important thing to understand is that translation phase is fast, but it still takes time. And you want to run your transactions as fast as possible. And so at the moment, if you sort of look at an execution profile of a contract when it's running today, when you invoke a contract, your transaction actually spends a fair amount of its time, in many cases as much as half or even 2/3 or 3/4 of its time, just doing the translation, getting it ready to run, coming from. So we pull the bytecode off of disk, and then we retranslate it, and then jump into it and execute it, and then basically throw that away. And the reason and then do it again for the next transaction and the next transaction, the next transaction. And we do this over and over and over again because we don't really have a clear way of, if we were to cache it from one transaction to the next, deciding who should pay for populating the cache and who should be able to basically free ride on things already being in the cache, and how to sort of reflect that in the fee model. There's a lot of complexity here. I don't really want to go into all the different options. I mean, I'm sure you can think of a way of making it work off the top of your head. Many people have. We talked about this a lot when we were developing the structure of Soroban, and we couldn't really come up with one that didn't have some weird incentive that allowed people to, price other people out of the transaction queue in a way that was unfair, or wound up making them overpay in certain circumstances in ways that we wouldn't be able to refund, or stuff like that. So ultimately, up until now, we have not done that. So up until now, for the first year or so of Soroban's existence, it has executed in this fairly wasteful fashion, where it is reparsing, retranslating modules from their serialized WASM form into their ready-to-run form on every single transaction. And that has been something we know. We want to get back to. We know we want to figure out the correct way to deal with it longer term and have longer-lived caches of that translated form. And so with CAP 62, our opening became obvious. This is the clear opening where we can do it. And in fact, we can do the most aggressive form of it, because there's this very large amount of data that will be kept in memory all the time, which is essentially the entire live part of the Soroban part of the bucket list. So that's levels of filtering here. But if you sort of step back, the contracts that are in the live portion of the Soroban portion of the ledger themselves, collectively, we've done some measurements, they're not very big. All told, it's 10 megabytes or something right now. It's not actually a ton of data. Even if we saw substantial growth in the blockchain, sort of all anticipated scenarios don't show it exceeding memory. And CAP62 really makes it clear that there's a model for bounding that growth, for controlling that growth, and for charging for it appropriately, so that as that growth occurs, we can manage essentially pressure on it to keep it under control, to have it not become arbitrarily huge. And that means the caching question just gets very simple. We just cache everything. As soon as something is pulled off of disk, we're just going to immediately compile and cache it. We'll translate it into its ready to execute form, and we'll just stick it in a reusable cache, and we'll reuse that cache from one transaction to the next. So all of the per transaction costs for translation go away. And that's the whole cap. It's actually very straightforward in the context of 62. So I've talked a lot to sort of give you the background for it, but the actual cap itself is utterly trivial. There's nothing to it. As soon as you turn it on, your costs just drop through the floor. Everything just goes faster and is cheaper. So pretty easy sell. I don't think there's an awful lot of reason to object to it, unless you can think of a reason why you don't want to avoid doing work multiple times. It's just a freebie. We really should have done this earlier on. It's just we didn't know how to make it work, and now we have a fairly clear model for making it work. So I've already implemented this. I've run the experiments on mainnet, running it in parallel on a local development validator, and it's much cheaper. Substantial cost savings. There are a couple of interesting corner cases to deal with in terms of like if you upload a contract and then try to run it inside the transaction inside the ledger that you uploaded it in. So if you do like an upload and run immediately, we have to be a little bit careful there in terms of like when the cache gets repopulated or incrementally populated with sort of new additions. But the worst case scenario of all of those is just that you get charged what you get charged today, which is you get charged the cost of translating it on the fly, in addition to the cache population, which we're just gonna eat those costs entirely. We're not even going to include the cost of cache population and eviction, because they're so much lower than the I/O cost of even bringing stuff in and out of memory in the first place. But there's a little bit of sort of careful accounting to make sure it all works. But essentially the user experience is just everything goes faster. So should be very straightforward. If anyone has questions, I'm happy to answer them, but I would be surprised, because there's really not much to this cap except cache work. And
yeah, so regarding to edge cases, can we maybe specify them explicitly in the cap, because I noticed that not quite specified, and like my current understanding from looking at the implementation is that we compile contracts specifically when we add entries to the bucket list, and we add entries to the bucket list specifically after running each and every transaction in the ledger. It also spawns a weird edge case where if you have an upload transaction and the transaction that calls an uploaded contract in the same ledger, or whatever your reason, then we basically have kind of an invocation of a contract that does not actually upload anything, but it still won't result in a cache heap. So
that's right. Yeah.
Yeah, I guess it is something to recommend. And I think, if Karen is here, I think it is something that we probably need to specify more explicitly in the cap with respect to the Y state. It's just that in this particular case, I don't think you can ever get the correct simulation result. Like, again, I don't know why would you do that, but simulation will probably assume, like, if you do not upload any contracts, then your contract has been cached. Like, every contract you're calling has been cached. And there is a third edge case scenario where it actually is not cached and it's not in memory. So basically, your fees and resources will be off. And yeah, I guess it's just worth pointing out in the cap.
Yeah,
like
I can clarify the conditions. I do, yeah. Like I think you're right in that that's a fairly edge case, because you would have to be simulating an execution of a contract that wasn't present on the chain on the assumption that maybe someone will upload it in the same transaction set as you.
Yeah, I don't know why
Which is
anyone does that, but protocol kind of has to handle this anyways.
sure, yeah, and it does. It falls back gracefully. It just is going to charge you more than you expected, and then your transaction would fail.
Okay.
But I'll document that in the cap. It's just
thanks. Just for posterity.
Yeah. Else. Okay, that was the easy one. So I guess we move on to the next one.
Yeah, it doesn't look like there are any questions. So, Dima, if you want to get started.
Yeah, sure. Commerce type and okay. Yeah. So yeah, cap 64. It's actually the cap itself is not that hard specification and implementation wise, but I guess the discussion here is more around the requirements and what we're trying to solve here. So for some background, memos are an element of every transaction, every stored transaction that are almost not observable by the protocol. The only thing that protocol does with the transactions is, well, it has to be signed as a part of the transaction envelope. But otherwise, memo is just some arbitrary payload that protocol has no concern thinking about. And it would be fine if it was just an arbitrary thing that has no value attached to it. Maybe it's marking transactions or something, but it happens that exchanges use memos for multiplexing, even though currently Store has so-called mixed accounts, which allow a single public key have a huge amount of different sub-accounts that are not represented on chain, but can be marked via some integer identifier. For historical reasons, most of the exchanges are just using the transaction memos. And the way it works is that when you want to deposit tokens from your own wallet to the exchange account, exchange would give you two values to consider when making a transaction. The first value is, well, the destination account, which is the normal Store account. And the second value is memo, usually some integer that is assigned to your account on that exchange. So basically, this way, exchange can maintain only a few public keys. They don't need to create a new account for every user. And for Store, it's actually very meaningful because on Store, there are no stateless accounts. Since the account is not just a public key, but literally a ledger entry, so you need to create it first. So it makes perfect sense that exchanges want this off-chain multiplexing for reducing the overall burden for maintaining large sets of users. That's kind of the historical background. Again, exchanges do use memos for better or worse. Mixed accounts are like more modern way to do that, but not actually being used not that much. Then when Soroban came out, it didn't care about memos for the reason I mentioned before. From the protocol perspective, on paper, memos do nothing. And this actually spawned kind of a vulnerability if anyone wanted to use memos in the context of the exchanges with Soroban. And I think there is a security, there is a post in the security sections of StarCore, the advisory, regarding this issue. I probably will not talk much about it because it's not super relevant because it has been fixed and no one has been affected. But the gist of it is that it is not possible for a custom account to sign for the transaction memo. And what this means is that, for example, imagine you wanted to deposit money to the exchange from your custom account, even if exchange could take Soroban payments without any issues. You actually have no way to sign the memo of the transaction. And if you recall, your account on exchange you're depositing to is actually a combination of some public key, so the account, and a memo. And yeah, when you're making a Soroban transfer, there is simply no way to sign for the memo. And in the context of vulnerability, that means that, well, if you were to attach your auth for the Soroban transfer to some storage transaction with a memo, the storage transaction by definition is signed by some classic account because, well, your transfer is a Soroban transfer from a custom account, and unfortunately, as of today, it cannot sign for the whole transaction. And then anyone could take your Soroban auth for the transfer and attach it to a different transaction with a different memo. It is obviously a vulnerability, but if you think about it, like, it is kind of unlikely that this situation would come up in the first place because, well, as I mentioned, like, you literally cannot make a Soroban transfer with a memo. So, like, the whole preconditions to this situation are kind of weird. Like, you need to have two accounts, both of which must be trusted, and only one of them is set in memo, the other one is not set in memo. So that's kind of the state of the thing, and the way, like, the protocol deals with the issue potentially shooting yourself in the leg by using memos with Soroban transactions in the exchange context that core simply does not allow such transactions to be present in the ledger. They are rejected before entering the mempool. But we still want to have some solution for interacting with the exchanges using the custom account. And Cap64 is about the most straightforward kind of solution that is hopefully the least necessary amount of work for the exchange to support, because it uses the old ways of using memos. It just makes them usable from the Soroban standpoint. And the way it makes memos usable from the Soroban standpoint is very straightforward. You just sign as a part of your Soroban authorization payload, you may set some memo that you expect to be present in the transaction and just sign for it explicitly when you are building your signature payload. Which basically makes it so you actually now can create a Soroban transfer operation from a custom account to some arbitrary exchange via account, and your signature will also be a signature of your memo. And then this auth payload will only be valid if it is a part of transactions that has a matching memo. So while you still need to have two accounts which you need to kind of trust, there is no way to actually prevent the there is no way to take your auth that you signed for Soroban and attach it to a transaction with a different memo, and there is basically no way to make the transfer not go where it was supposed to go. And obviously, the next step would be, like, if you were to implement it, I must make it clear, like, even if you were to use it, like, there is no guarantee that exchanges will support it, but at least in order to support that, they just need to increase the scope of the transactions that they're monitoring, right? Because I would imagine, like, on a high level, like, I don't have access to their code, obviously, but on a high level, what they would do is they would look at the incoming stream of transactions, somehow identify the payments, and then look at the payment transaction and identify the memo. With this change, they will need to also look at the Soroban transfer operations. Again, meta should look the same in terms of, like, having the balance of the account increased. Then Memo is in exactly the same place of the transaction as it is for Classic. So this is the cap. The payment operations to C address, it is like an opposite. But basically, when you think of interaction with the exchanges, there are two operations you want to support. It's deposits and withdrawals. Meaning deposit is I have my wallet, I want to send money to the exchange and then do some trading on the exchange. And withdrawal means I have some balance token on my non-custodial exchange account and I want to move it back to my crypto wallet that I own. This is withdrawal. And payments to C address are actually about supporting withdrawals. So it is kind of related, but it's not in scope of this cap. And I'm not sure like if you're doing it for this protocol or we are doing this at all. But the current cap is specifically about deposits. Yeah, so this is basically what is proposed, and there are obviously alternatives such as like, hey, why not use Nux accounts? And as I mentioned, well, exchanges don't support them anyway. And then, hey, why not come up with a solution for Soroban multiplexing? And again, exchanges don't use it yet, and it is incomplete thing, and it probably requires much more design work, and there is no very obvious way of how to do multiplexing with Soroban that is also meaningful. So what this cap does is basically kind of fixes an immediate issue we have, but it does not close the doors for future modifications or coming up with new ways of multiplexing accounts and Soroban. But this one seems like the best thing we could do. That is like it has probably the biggest overlap with the existing infrastructure, existing approaches that are used out there. Everything like other solutions would be probably much more divergent from what happens now, and it kind of reduces the chance for the adoption. Okay, I think this is it for the overview. Now to the questions. Yes. Memos and the events are currently not specified. Like this cap does not talk about the events, which makes sense. It is about authorizing memos, but the cap that we have created for the next week that is still under the active discussion is about trying to generalize the events between Classic and Soroban. So we need metadata for Classic operations in the event format so that you don't need to write custom parsing logic for Classic and Soroban. And memos may be a part of this event stream in some case. But yeah, I don't know if we want to discuss this now or not as a part of this discussion. Yeah, and yes, in general, on a more, I guess the main philosophical question about this cap is really if we want to support memos at all, because they're kind of bad and people have issues with them, and I think there is some merit to it just because of historical reasons. And if other folks disagree, then maybe pick up. in the chat. So maybe if someone wants to jump on the stage, that might be useful as well. Lee wants to call out that cap64 still has memory in the system domain. Yes, it basically, I would say, my opinion, this is that memos do exist and they are being used for now, for better or worse, and it makes sense for Soroban to support them for the time being. If we have a better generic solution for that, we probably should try to come up with a separately and just try to deprecate memos. So my expectation is that it will take a long time before it can be fully deprecated with this portion. Again, if anyone wants to speak up, maybe we just feel awkward waiting while everyone is typing.
Sounds like there's some more to discuss related to the memos, but it doesn't. It should affect Cap64, right?
Yeah, I feel like
Today.
the event discussion can be continued synchronously. But before we move on, I just want to ask everyone again, if anyone has any strong opinions in terms of why you shouldn't do Cap64, please speak up now. Yeah.
G'day. I understand that the Cap64 as it is very, very narrow. The use case is it's very hyper focused on addressing the existing classic use case, and it's really surgical just to address the problem there. Is there, and I understand, like, Tome is bringing up, why not solve this in a way that works for more than that? Yeah, and I get that. I guess my question is, like, there are some advantages. So even, I mean, obviously, like, if we can solve this in a more generic way, that would be pretty cool. And we probably can, but there are also some advantages if we do solve it really surgically, because we sort of can rework back to the transaction memo being something that you can rely on. And so I think that's valuable, but maybe that's not valuable. So I'm not actually sure, Tomer, if you're saying that that's actually not as valuable as what I think it's valuable, or what some other of us think is valuable. If we do think that's valuable, is there anything about this proposal that prevents us from loosening this constraint in the future? Like, if we go ahead with this proposal, the network adopts the proposal, and transaction memo is what exchanges can continue to rely on. In a year from now or 6 months from now, can we loosen the requirements so that every auth can have its own memo, or every transfer can have its own memo, or something like that? Like, are we sort of going down a path where it's going to be really difficult to walk back?
Right. So there are several things here. Let me start with why don't we drop the requirement for text memo to match that transaction memo? I don't think it's a good idea because unlike the memo, basically the transaction memo, when you observe a successful transaction, without doing any additional work, you can say that parties have, all the parties have signed this memo. And in case of app64, you can also say that the relevant Soroban parties have signed for this memo as well. If you have a transaction that has some Soroban auth and there is no requirement for the memos to match the transaction memo, when you're looking at the transaction, you cannot tell anything about the nature of this auth payload. Because, like, besides, like, minor space optimization, I think the main context this comes up in is, hey, why don't we use it to allow something like payments to multiple multiplex destinations at once in the same transaction? Well, the issue is that if you keep relying on the transaction, unlike in case of memos, you actually don't have any confidence for any given auth that it has been used and the memo has actually made the payment go through and so on. So basically, you put a lot more demands on tying all the pieces of data together on the downstream system. So not only do they need to jump from the event to the transaction, but they also need to make sure that there are events for every auth present in the transaction and everything matches this instance. Nothing basically, yeah, there is no extra payload or something like this. And I think it is really put gunny. And like if someone forgets about this check, then they can be tricked into thinking that something has been transferred to them by attaching an extra entry of Soroban auth with some extra memo that maybe, you know, matches the destination account of some other legitimate auth in there or something like that. So basically, it is like given that Soroban auth is really flexible because like really it has to support custom accounts and you do not verify it beforehand. You can only verify it during the contract execution. It's actually being consumed. I don't think it's a good idea to just put memo in there without any ties to the actual transaction memo. So here, basically, like the fact that it's tied to the transaction memo ensures the fact that like there is no ambiguity there in terms of like memos are actually getting. And I do recognize that it's really restrictive, but I think it's also for the better for now. And for a more general solution, I think it should have something to do with the events so that you don't need to do any work downstream trying to figure out like if this is the right memo, right multiplexing ID for this particular event. Like, I think instead events should explicitly tell what is this multiplexing ID that confirms this particular event. And I think this is why this whole discussion about the events have started up, because like if you were to come up with a solution that is event-based, then it would probably make sense to also involve the current memos and the events to just keep the generic schema across all the different types of operations. Okay, now I need to read the comments again. And yeah, I think if yeah, to the question if we can relax this requirement, I like given the security implications, I'm not sure it is a good idea. But again, as I said, I'm not sure it's a good idea in general. Like, I think we need a bit different approach. Unless, of course, we figure out how to tie the memo from the auth engine to the event. I'm not sure if it is possible at all. So the question about like centralized exchanges would need to make some code changes either without no change. The issue is that without that memo change, we actually basically some sort of memo support is a requirement to support deposits. Like it's not the only thing to do, but it is a requirement because if they cannot do multiplexing, I think it is very tall ask to ask them to create an actual physical account for every user, and it's not suitable for the network at all. So basically, like if you don't propose any multiplexing solution at all, I think there is no way to ask exchanges to implement anything. So we need at least something, and the argument for this cap is that well, this something is very close to what they're already doing. Whereas if we try to come up with some other more general system that's also contingent on adapting well, this whole system, whatever it is. I don't know yet what it is. What's going on Horizon with all everything in transfer. To add some context, like I recall there may have been some discussions here on Discord about supporting mixed accounts in Soroban in general, and the tricky thing about any sort of multiplexing in Soroban, and the reason for why we are not like coming in with some maybe more generic multiplexing app, you're not coming out with one yet, is that since in Soroban you kind of manage your own storage, it is tricky to distinguish between cases when you do care about multiplexing and you don't care about multiplexing. For example, consider a classic mixed account. Let's say you have a transfer, and let's say we just add it to the Soroban address. Well, when you store the balance in your, for example, in your custom token for a multiplexed account, then you specifically want all the multiplexed accounts to be stored under the same key. But when you're emitting events, you specifically want the event to contain the multiplexed account as destination. And when you're verifying auth, you also want to make sure that you're sending the transfer happens to the exact multiplex account which has been specified in the transaction. And I'm not sure if there is a generic way of basically for the contract developers to be aware of like when they should or shouldn't treat accounts as multiplex. And this is the primary reason for why like mixed accounts are not supported by Soroban at all today, and it's also the reason for why like there's no great solution for multiplexing in Soroban yet. But maybe we can think of something that is not doing anything the contract layer maybe, but again, I'm not sure yet how could it look like. It's another argument for why we have doing something simpler, even though it's less ideal. Okay, I think if like, do we have any remaining topics that need to be discussed now? Because I guess we can continue the managed horizon discussion synchronously.
Yeah, I'll leave a link to the discussion in the chat and we can continue there. But it doesn't sound like there are any more immediate questions for Cap64 at the moment.
Yeah, and then Omar's still typing, but yeah. Yeah, let's return first. I've expressed my opinion. We can continue discussion. The discussion thread if someone has.
Yeah, we can
Yep.
we can continue discussing in that thread. And it sounds like that's it for today. So thanks, Graydon and Dima, for presenting, and thanks everyone for listening. We'll see you next week, unless Lee or George have any questions. Start typing. All right. That's it then. See y'all next week.